हाँ मेरे को याद है. So before we go on to the concept of potential energy, which I think we'll be able to finish today, I want to show you a class of questions which will stay with us for a very long time. That means that whatever I'm about to teach you today, this will be the main feature of physics for the remainder of our syllabus. That means that the mathematical technique that I'm going to discuss today will be used in the next chapter very predominantly. उसके बाद वाला chapter, उसके बाद वाला chapter. Every chapter from now till the end of the syllabus will be using this technique very predominantly. Okay? So I hope everybody is here. कोई सो नहीं रहा है और सब लोग यहाँ पे ध्यान दें. Right? This is something very, very new to you. So you need to really understand what I'm doing. I'll do it very, very slowly. Okay. So what we are going to do today, discuss today, is the physics of discrete and continuous systems. Okay, the physics of discrete and continuous systems. So a system in physics, system is, remember, it is any object that you have chosen or any boundary that you have chosen. That would be a more superior definition. So you can choose the boundary of, you can choose the boundary anywhere, and you can say that, look, whatever is inside the boundary is my system. Whatever is external to the boundary is something external. Okay? So the system that you have chosen, the bubble that you have made, you can make it anywhere you wish. You can choose the driver and half the car as the system. You can choose the driver and the steering wheel as the system. You can choose the head of the driver as the system. It's your choice. So whatever system you may choose, reconnect kar lo. Whatever system you may choose, okay, that system may either be discrete or continuous, or it may be a mixture of the two. Okay? It may be a mixture of the two. So what do we mean by discrete system and what do we mean by continuous system? I'll tell you by an example. Supposing that I have a glass, normal जो हमारा पानी पीने का glass होता है शीशे वाला. I have a glass which is filled with marbles. Okay? And I have a glass, another glass, identical glass, which is filled with water. Okay? So this is water, and these are marbles. Okay, so now what I'm going to do is I am going to drop the contents of these two glasses onto a weighing machine. Okay, I'm going to drop the contents of these two glasses onto a weighing machine. Now we will assume that the weighing machine is ideal. That means that it will not record the jump in the weight when the marble or the water lands on it. Okay. Remember that the weight of an object when it hits the ground from above, falling from above, the weight of the thing will be uh, very large for a very small period of time. After all, अगर मैं आपको बोलूं कि एक ब्रिक को अपने सर पे रखना है, that should not be a problem for any of us. लेकिन अगर मैं बोलूं कि उसी ब्रिक को मैं 2 फ्लोर ऊपर से सर के ऊपर गिराऊंगा, that will be a problem for all of us. But the brick is the same, the mass of the brick is the same. The difference is that if you keep the brick on your head, then you only experience the weight of the brick. Assuming that the brick is 1 or 2 kilos, that means you are experiencing 10 or 20 newtons on your head, which is no problem. But if the same brick drops from the second floor, then it hits your head where you are on the ground, then there will be all sorts of problems, because as the brick hits your head, not only is your head uh, supporting the weight of the brick, it is also making the brick accelerate, or in layman's terms, deaccelerate. And therefore, the force applied by the brick on your head will be much larger. Okay. So I have a weighing machine which does not, or which will not register this increase. It will only give us a reading of whatever is on the weighing machine at that moment in time. Okay? तो जब मैं इसको गिराना शुरू करूंगा वेइंग मशीन के ऊपर, पहले मैंने ये मार्बल्स वाला ग्लास उठाया और वेइंग मशीन के ऊपर गिराना शुरू किया, राइट? अब मैंने ये तो बोल दिया कि वेइंग मशीन उसका वो नहीं रिकॉर्ड करेगी जो वेट इंक्रीज होएगा सडन, बट हमको आवाज जरूर सुनाई दे रही है मार्बल्स गिरने की. नाउ इफ आई ड्रॉप or if I pour the glass of marbles slowly, that means that I want at a time only one marble to fall off. Then, what will you hear? What will you hear? अगर मैंने ये ग्लास ऑफ मार्बल्स स्लोली वेइंग मशीन के ऊपर पोर किया एक हाइट से, और एक एक करके ये मार्बल्स वेइंग मशीन पे गिर रहे हैं, तो आपको क्या सुनाई देगा? What will you hear? What will you hear? Anyone? हाँ, it is not a very technical question. It is not a trick question. मार्बल गिरेगा, आपको एक आवाज सुनाई देगी, and we are assuming that there is no bounce. Okay, so there is no bounce. So the first marble hits the weighing machine, you hear a thud. Second marble hits the weighing machine, you hear another thud. Now, if you are not facing the weighing machine, can you or will you be able to tell me the number of marbles that have landed on the weighing machine just by listening to the sounds? Given that uh, 2 marbles will never fall simultaneously and that there is no bounce, will you be able to tell me the number of marbles that have fallen on the weighing machine? Will you be able to tell me the number of marbles on the weighing machine? Yes, you will. All you have to do is count the thuds, right? Bad, 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 get you're just counting. Okay. Now, if each marble weighs 100 grams, okay, if each marble weighs 100 grams, then what do you think will happen what do you think will happen to the reading of the weighing machine? What will happen to the reading of the weighing machine? What will happen to the reading of the weighing machine? Well, the reading of the weighing machine must be 0, and then it will become 100, and then it will become 200, and then it will become 300, and then it will become 400, then it will become 500, and so on. Will there be a situation where the reading of the weighing machine will be 250 grams? Will there be a situation where the reading of the machine will be 250 grams? Will there be a situation in the weighing machine where the reading will be 250 grams? No, there will not be. Why? Because each marble weighs 100 grams. And the weighing machine, which is very accurate, अरे बाउंस नहीं कर रहा है विश्वजीत, बोला ना मैंने, it is not bouncing. So after the first marble falls, the weighing machine reading will go from 0 to 100. Second marble falls 100 to 200. Third falls 200 to 300, and so on. The reading of the weighing machine will never ever be 250 grams, 230 grams, 240 grams, 237.5 grams. Never. It will go from 200 to 300 grams. That's it. Will you, by listening to the sounds of the marble falling, be able to say कि नहीं अब तो 2.5 marble गिर गया है, 2.5 marble गिर गया है? Will you be able to say this? Will this be a meaningful statement? What would it mean? 2.5 marbles अब गिर गए, 3.25 marbles गिर गए? No, it would be a meaningless statement. Meaningless because the marbles are a complete entity in themselves. They are non-divisible, right? Or at least we are assuming that they are non-divisible. गिर के टूट गया, ये सब हम नहीं assume करते. So a single marble then will produce a very defined effect. It will produce one sound when it hits the weighing machine, and it will increase the reading of the weighing machine by 100 grams. Right? This will be the effect of the marbles, and such a system is called a discrete system because you can count the number of components of the system on your hand. You can then say 1 marble gira, 2 marble gira, 3 marble gira, 4 marble gira, right? So you can count the components of the system, you can count the contents of the system on your hand, right? And they are absolutely distinct from each other. एक marble यहाँ है, दूसरा marble वहाँ है. On the other hand, if I decide to pour the water on the weighing machine, on the other hand, if I decide to pour the water on the weighing machine, will you hear the individual thuds? Will you hear the individual molecules striking the weighing machine? Is that possible? No, you will not. Okay. What about the reading on the weighing machine? What about the reading on the weighing machine? Will it be going up in discrete quantities, 100, 200, 300, assuming that our weighing machine is very sensitive? The reading on the weighing machine will be going up continuously. तो अगर मैंने 200 grams water pour किया, अगर मैंने 200 grams water pour किया, तो from the moment I started to the moment I stopped pouring the water, the reading of the weighing machine would have acquired every value between 0 and 200. Would you agree with this? That means that while I am pouring the water, the reading on the weighing machine at some moment in time would have been 100 grams. At some moment in time, it would have been 115 grams. At some moment in time, it would have been 115.1 grams. At some moment in time, it would have been 115.2 grams. At some moment in time, it would have been 115.21 grams. उसके बाद से 115.213 grams. उसके बाद से 115.2135 grams. Depending on the number of decimals on my weighing machine, the reading of the weighing machine will go exactly like a stopwatch. Okay? आपने देखा है आपके मोबाइल में या घड़ी में जो स्टॉपवॉच होता है उसमें 100 सेकंड का भी रीडिंग होता है. वो कैसे मूव करता है? It actually goes from 1 to 9, and the moment it goes beyond 9, then the next digit changes by 1, and when the next digit goes through 9 and then that also changes, then the left wala digit changes by 1. Right? Stopwatch तो सबने देखी हुई. तो अगर मैं एक स्टॉपवॉच को स्टार्ट करता हूँ और 10 सेकंड बाद मैं स्टॉपवॉच को बंद करता हूँ, will you agree with the statement that at some point of time the reading of the stopwatch was 5.67 seconds? Okay, you need. I think it will be almost impossible for humans to stop it at 5.67, but the reading at some point of time in the stopwatch would definitely have been 5.67 seconds. If I have a more accurate stopwatch, then the reading on the stopwatch at some moment in time would have been 5.675 seconds. At some moment in time, 5.6751 seconds. Now it depends on the accuracy of my stopwatch and the number of digits that I have decided to put on the stopwatch, which will tell me कि भाई हाँ कहाँ तक मैं decimal places consider कर सकता हूँ. My claim is that a similar thing will happen to the reading of the weighing machine as I pour the water on the weighing machine from 0 to 200 grams. Of course, assuming that I'm pouring the water at a very constant rate. ऐसा नहीं हो रहा है कि मैंने एक बार एक ड्रॉप डाला फिर उसके बाद थोड़ा और डाल दिया फिर थोड़ा और नहीं ऐसा नहीं. So such a system where it is impossible for you to count the components. Okay? Such a system where it is impossible for you to count the components is called a continuous system. Okay, it is called a continuous system. What we have been learning up till now is the physics of discrete systems. Okay, एक लिफ्ट के अंदर एक आदमी है, उसने रस्सी पकड़ी हुई है. डिस्क्रीट सिस्टम, एक वेज के ऊपर एक ब्लॉक रखा हुआ है. Discrete system, wedge, something that you cannot break down. Wedge is one object, one component of the system. Block is another component of the system. Therefore, this is a discrete system. You can count, you can say that my system consists of two objects, the block and the wedge, the man and the lift. So these are all discrete systems. We have not yet discussed how to deal with continuous systems, right? So today I'll show you how. The moment you see continuous systems, you must, prepare yourself that you are going to use calculus, and the way that you are going to use calculus is also going to be predefined. And I will tell you the way that you are going to use calculus today, but we will have a much more detailed much more detailed discussion in the next chapter, and many examples in the next chapter. So to deal with discrete systems, we have already seen. To deal with continuous systems, what you are going to do is divide the continuous system into what I am going to call elements. Okay? So we are going to treat a continuous system as a discrete system but the individual components of the continuous system are going to be infinitesimally small. Okay? Therefore, calculus will come in. Right? So this is an element. So what I've done is that I've taken a very, very small cube here, and I say that, look, this body of water is nothing but a collection of these small cubes. Huge, huge collection. Of course, uh, there is a huge number of this. In fact, so huge that I'll simply call it infinity. So this body of water, this glass of water, is actually made up of these infinitely many elements. And one element is a teeny tiny cube. Is this teeny tiny cube smaller than the molecule of water? No. In physics, what we will try to do is that we will take an element which is having a geometrical size which is infinitesimally smaller than the size of the whole system, but it contains a lot of atoms and molecules, right? Because the individual molecules, they are not going to behave like water. I hope you have read this in class 10, or you have read this generally, that individual molecules of water will not behave like water. ऐसा नहीं है कि आप एक एक मॉलिक्यूल वाटर अपने मुंह में डालोगे तो आपकी प्यास जो है बुझ जाएगी. It will not happen. But a collection of uh, molecules of water will definitely will behave like water, right? Large collection. So this little red cube that I have drawn has dimensions which are infinitesimally smaller than the dimensions of the glass of the water. However, each cube will consist of a very large number of molecules of water. 1 लाख से लेके 10 लाख मॉलिक्यूल हैं इस ट्यूब के अंदर. Okay, so the first step of dealing with continuous systems is to divide the system into elements. Now, this needs more discussion. So I'm going to change the slide. Please take a screenshot. Please take a screenshot. Please take a screenshot. Please take a screenshot. Okay, चलो आगे बढ़ रहा हूँ. So, supposing that I have been given or supposing that I'm dealing with a chain, I'm dealing with a chain or a rope, or basically an extended mass in one dimension. Okay, I'm dealing with a chain or a rope or extended mass in one dimension. Then what do I do? How do I deal with this continuous system, right? I hope you are agreeing with me now that a chain or a rope is a continuous system. It's continuous because it exists various points in space, and इसका जो individual component है, आप उसको you cannot point it out, you cannot count it. You cannot count it. I know आपके मन में आ रहा होगा, अरे चेन में तो काउंट कर सकते हैं इंडिविजुअल लिंक्स, लेकिन नहीं. अगर ये वर्ड चेन यूज हुआ तो वी विल से दैट If you are indeed talking about the individual links, then the individual links are extremely teeny tiny, teeny tiny. There are a huge number of links. इसी तरीके से रोप में मास जो है वो पूरा वो है spread out है over the length of the rope. Now you may think at this point कि एक ब्लॉक में भी तो मास spread out है, एक वेज में भी तो मास spread out है, but the point is that एक रोप में जो मास spread out है उसमें डिफरेंट मासेस का मोशन डिफरेंट हो सकता है. फॉर एग्जांपल I have a table, and on this table this rope is there and it is overhanging. Now what if I were to pull the rope in this direction? If I were to pull the rope in this direction, then this guy would have a velocity like this, and this guy would have a velocity like this. So the individual parts of the rope or the chain can have different motions. This is a possibility. Whereas if I have a block or a wedge, तो ब्लॉक का कोई इंडिविजुअल पार्ट में लूंगा और कोई और इंडिविजुअल पार्ट में लूंगा तो they will both have the same kind of motion. ऐसा नहीं हो सकता कि ब्लॉक का एक पार्ट ऊपर जा रहा हो एक पार्ट हॉरिजॉन्टली जा रहा हो. फिजिकली हो सकता है, फिजिकली आप अपने पेन को अगर उसके एक एंड से उठाएंगे तो जिस एंड से आप उठा रहे हैं वहां के पास वाले एलिमेंट का मोशन दूसरा होगा और जो एंड टेबल पे पड़ा हुआ है उसके पास वाले एलिमेंट का मोशन दूसरा होगा. This is the topic for the next chapter, which is called the rigid body dynamics, where I am going to discuss the fact that bodies which have length, breadth and height, how to deal with them in mechanics. लेकिन अभी तक जो हमने ऑब्जेक्ट्स पढ़े हैं they are based on the concept of the point particle which I discussed with you in the first class. Okay, so the block that we have dealt with, the wedge that we have dealt with, the pulley that we have dealt with, they are all objects which are existing in an ideal world, and this block, this wedge, this pulley, they do not have edges, they do not have lengths, they do not have breadth, they do not have height. Okay, they are point particles. In fact, in the first class I told you कि अगर मैं एक कार भी बनाऊंगा और उसके अंदर आदमी रहेगा ये भी एक पॉइंट पार्टिकल की तरह ही हम ट्रीट करेंगे. So is a block a continuous object or a discrete object? Well, for the moment it is a discrete object, but in the next chapter it is going to become a continuous object. Okay, so how to deal with objects having length, breadth and height, we will deal with in the next chapter. Here, if you will notice, I will deal only with chain and rope because these are objects which have mass in one dimension. A block, okay, I will deal with in the next chapter. A sphere, I will deal with in the next chapter because these are objects which have mass in spread out in 2 dimensions or 3 dimensions. Okay. So how do you deal with an extended object, extended mass in one dimension? इसका मतलब कि एक ऐसा ऑब्जेक्ट है हमारे सामने जिसका मास स्प्रेड आउट है, लेकिन ये जो स्प्रेड है this is only in one dimension. We don't see objects like this in our daily lives, no, because अगर एक रोप और एक चेन हम देखेंगे भी अपनी डेली लाइफ में तो इट इज ए 3 डायमेंशनल ऑब्जेक्ट, उसका लेंथ होता है, उसका क्रॉस सेक्शनल एरिया होता है, therefore it is existing in 3 dimensions. It is mass distributed in 3 dimensions. But again, to to give you an idea of how to deal with extended mass, how to deal with mass which is spread out in space, I will start with 1 dimension. Then we'll go on to 2 and 3 dimensions. Okay. So at this moment, we will not assume that there is a cross-sectional area to this rope. However, right? However, if I do say that there is a cross-sectional area, then we will assume that this cross-sectional area is very small as compared to the length of the rope. So again, we are only dealing with mass distribution or extended mass in 1 dimension. Okay. I hope I have made this clear. Any doubts you have, please ask me. मैं सबको unmute कर दे रहा हूँ. Okay, अपने आप mute कर लो अपने आप को. Any doubt you have at any moment in time, simply ask me. Drashti, Zohaib, mute कर लो अपने आप को. Whenever you want to unmute, you unmute and you ask. Okay? Zohaib, mute कर अपने आप को. नहीं गाड़ी का वहां से हॉर्न वहां से आएगा. So I hope I've made this clear that we are going to deal for the first time with an object whose mass is uh, distributed over space. But we are limiting ourselves to an object whose mass is distributed in space in 1 dimension. Okay? That is what is a chain and a rope. बोलना यार अब लिख मत. So we are moving from point particle to distributed mass in 1 dimension. Yes, we are moving from point particle to. अब अगर आपके सामने ऐसा कोई ऑब्जेक्ट आया, then this is a continuous system. You cannot simply apply F is equal to ma here. अगर ये स्ट्रेट सरफेस पे चल रहा है, you can apply F is equal to ma. ये वाला जो मैंने डायग्राम बनाया है नीचे वाला, राइट, यहाँ पे F is equal to ma नहीं अप्लाई कर सकते हैं. कैसे डील करना है मैं बता रहा हूँ. I'll show you. So like I said, the first step is to divide the continuous system into elements. Okay. Divide the continuous system into elements. Let me write here also. I want to write here first step. Okay. Okay. How do we divide the system into elements? Well, I hope that all of you have played this game called Fruit Ninja. Right? सबने खेला है ये, या एटलीस्ट देखा है. आई होप सबने देखा है. तो उसमें गेम में क्या होता है, या हो सकता है जनरेशन गैप हो भाई, आप लोगों ने नहीं देखा हो. तो उसमें क्या होता है कि एक मिनट, जस्ट So the game of Fruit Ninja involves a sword, and you are holding the sword in your hand, and they throw some fruits at you in the video game, of course, and you are supposed to cut the fruits with the sword, right? बहुत अच्छा game है. So just like the Fruit Ninja, if you have played, or if you have not played, we are taking a sword, okay, and we are going to sort of, because ninja word आ गया ना यहाँ पे, we are going to इसको हम infinitely thin slices में काटेंगे, infinitely thin slices में काटेंगे. And then what we will do is we will say that, look, I am looking at this particular slice, which is chosen arbitrarily. मैंने arbitrarily choose कर दिया. So I am looking at, overdraw कर दिया. I'm looking at this particular slice. That's it. There are infinite slices. I'm not bothered. I'm only looking at this particular slice. Okay. So step one is to choose an element, and the way that you choose an element for a chain or a rope or anything which has a mass extended over one dimension is to slice it up into thin slices, just like आपके घर में cucumber को salad में काटते होंगे ना, और पत्ते slices में. So you take that one slice of this object, one slice, and after you have chosen this slice, which is arbitrary. Arbitrary का मतलब, you can't say that I will choose the slice at the very end, or I will choose the slice at this end, or I will choose the slice at the middle, or I will choose a slice at a distance of L by 4 from one end. No, you can't do that. It has to be arbitrary. Arbitrary का मतलब random. Okay? Random का मतलब आप ये नहीं बता सकते मेरे को अब कि ये एंड से ये जो मैंने स्लाइस बीच में चूज किया है, you cannot tell me what is the distance of this object from this end. Okay? That is the meaning of random, arbitrary. And then comes step 2. Step 2. Step 2 is to assign a new variable to locate the element and a corresponding d term for the element itself. Right? So this means that you are going to choose, and you're going to say that, look, you're going to choose a new variable, and you're going to say that, look, the distance of this object from one end of the chain is x. Therefore, the width of the object must be dx. And whatever variable you choose must be here. You cannot say that this is y and this is dx. ये नहीं कर सकते. अगर ये x है तो ये dx होएगा. अगर कोई और ये क्वेश्चन कर रहा है और वो बोले कि यार मैं तो यहाँ से डिस्टेंस लेना चाहता हूँ और ये y डिस्टेंस लेना चाहता हूँ, तो ये dy हो जाएगा. Okay? This is depending the length of the element, the d term will be dependent on the new variable, must be the same as the new variable that you have chosen. ये आया सबको समझ में? Is this understood? Okay. अब अर्जुन की कहानी सबने सुनी है. अर्जुन एक कैरेक्टर है महाभारत में. उसकी कहानी सबने सुनी है. तो I think this guy called Dronacharya, who was the teacher, was teaching them how to shoot an arrow. Okay? And he asks each one of them कि भाई तेरे को क्या दिखाई दे रहा है. तो सबसे पहले आया एक कोई, I don't know कौन आया. तो they have to shoot a bird who is sitting on a tree, right? Highly unadvisable, but at that time I don't think there was any wildlife problem. So they are supposed to shoot a bird sitting on a tree, and this guy Dronacharya calls the first student and he says that, what do you see? So the student says कि मेरे को पेड़ दिखाई दे रहा है, मेरे को चिड़िया दिखाई दे रही है, मेरे को पत्तियां दिखाई दे रही हैं, मेरे को आसमान दिखाई दे रहा है. तो द्रोणाचार्य सेट की नहीं, तुझसे नहीं हो पाएगा, तू आगे बढ़ चल. फिर अगले आया, उसको वो बोलता है कि नहीं मेरे को चिड़िया दिखाई दे रही है, होता है नहीं तेरे से भी नहीं हो पाएगा, बिकॉज the exercise was very specific. You had to shoot the bird in the eye, right? Very cruel thing to do, but you had to shoot the bird in the eye. So the guy says मेरे को चिड़िया दिखाई दे रही है, अगर तुझसे भी नहीं हो पाएगा तो आगे बढ़. Then this guy Arjun comes in and Dronacharya asks, what do you see? अच्छा वुडन बर्ड था क्या, मेरे को क्या मालूम. तो when Arjun was asked what do you see, then Arjun says that I can see only the bird's eye. I can see nothing else. Okay, that is what you need to do here. Once you have chosen the element, once you have assigned a new variable for the element and you have assigned the d term for the element, then the only thing that you can see now is the element. You forget about the rest of the object. Okay, you forget about the rest of the object. The only thing, just like Arjun, only see the element. And whatever has been asked from us, whatever has been asked from us, ये क्वेश्चन में जो भी पूछा गया है उस चेन के बारे में, you are going to work it out for that element. Okay, and then you are going to say that, look, since you have asked me for the whole chain something, right, that may be potential energy, that may be change in potential energy, that may be work done by friction, that may be anything, kuch bhi pucha gaya. So in this question I'm going to ask you, what is the work done by friction? You are only going to first figure out the work done by friction on this element, and then we are going to say that, look, the work done by friction on the whole chain, okay, must be the same as the work done, the sum of work done of each and individual element, right? अगर मुझसे कोई physical quantity पूछी गई है for the whole chain, then that physical quantity must be the sum of the physical quantity associated with each element. So to find it for the whole chain, once you have found it for one element, all you need to do is add things up. And when you add things up, there is a d term involved. That means you will have to carry out. You will have to carry out integration. Integration. Okay. So step 3. Find the relevant physical quantity for the chosen element. Step 4. Integrate to find for the whole system. Okay, please write this down or take a screenshot. है, हो गया, स्क्रीनशॉट ले लिया, लिख लिया, आगे बढ़ूं मैं। हम लोग का ये नेक्स्ट क्लास कब है, कल है क्या? सैटरडे को है। Find the work done by force F. Pull the rope completely on the surface of table. पूरा आएगा सर बेटा, पूरा जो मैं सैटरडे को पढ़ाऊंगा वो भी आएगा। हाँ पूरा। पर ठीक है, अब कुछ ज्यादा बचा नहीं है, ज्यादा बचा नहीं। Okay, so first I want to explain what is the meaning of the word slowly. I'm going to do this question. Please see how to do this question. So slowly का मतलब होता है there is no change in kinetic energy. This is the mathematical meaning of slowly. अगर word कहीं पे use हो गया that something is done slowly, right? That literally means that there is no change in kinetic energy. इसका मतलब कि अगर initial velocity object की या system की zero है, तो उसकी वेलोसिटी सिस्टम की हमेशा ही जीरो रहेगी। इसका मतलब कि ये फोर्स F इस तरीके से लगाया जा रहा है that at some point it pulls up a very small length of the rope, उसके बाद से वो रुक जाता है। फिर उसके बाद से एक आध महीने बाद फिर से the force will be increased infinitesimally so that a very small length of the rope goes onto the table and फिर अगेन वो रुक जाएगा 2-3 महीने के लिए। करते 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 20 साल बाद ये रोप टेबल के ऊपर पहुंच जाएगी। Point of the story is that if you are ever there to see the rope and the person applying the force, Okay, you go in the room where this experiment is being carried out. You will always register the velocity of the rope to be zero. आप जाओगे आप बोलोगे अरे ये तो हिल ही नहीं रहा है ये तो क्या बकवास है ये. But if you go back after a couple of years, you will find that a portion of the rope has gone up the table. Okay. तो ये तो कहानी है सिर्फ, but the mathematical meaning is that change in kinetic energy of the system is zero. Slowly का मतलब change in kinetic energy of the system is zero. Okay, now let's apply this new concept that we have learned. So this is a continuous system. Okay. So what we need to do with this continuous system is we need to chop this up. यहाँ पे chop किया थोड़ा सा, यहाँ पे chop किया थोड़ा सा. And now we need to bring in a new variable to measure the length or to measure the distance of this chosen element from somewhere. Let's see from where. I am interested in this. I am interested in this portion. I am interested in this portion. Why am I interested in this portion? Why am I not interested in this portion? Well, the thing is that this guy right here, इसका motion बहुत ही uninteresting होने वाला है, because as this force pulls this rope onto the table, right? This guy will be moving horizontally. Okay? This guy will be moving horizontally. इसका motion is very uninteresting. Whereas this guy, as the rope is pulled up, will be moving vertically. Right? So I can sort of think about writing work done by the earth. Okay. Next is कि मैं कहाँ से डिस्टेंस कंसिडर करूँ. मेरे को तो नया वेरिएबल लेके आना है, तो ये डिस्टेंस कहाँ से कंसिडर करूँ के तीन ऑल्टरनेटिव्स. ओके, पहला ऑल्टरनेटिव ये है कि मैं यहाँ से डिस्टेंस कंसिडर करूँ ऐसे. दूसरा ऑल्टरनेटिव ये है कि मैं ऐसे डिस्टेंस कंसिडर करूँ. तीसरा ऑल्टरनेटिव ये है कि मैं यहाँ से डिस्टेंस. Let this be alternative 1, let this be 2, let this be 3. Which do you think should be best? So there is a key difference between alternative 1, 3 and 2. Alternative 1 में मैं कहाँ से measure कर रहा हूँ? I am measuring from one end of the rope. Alternative 3 में कहाँ से measure कर रहा हूँ? I am measuring from the other end of the rope. Alternative 2 में मैं कहाँ से measure कर रहा हूँ? From the edge of the table. Out of these three, which do you think I should? हाँ, good. Yes. हाँ, नहीं हमें गलत है ये. No, Dhanush, no. See, whenever you measure distance, yes, sir. Whenever you measure distance, it must be from a fixed point. Otherwise, तब तो लोचा हो जाएगा ना. लोचा हो जाएगा ना. मैं अगर कार में चल रहा हूँ, I am going from, let's say, नेरुल to थाने, तो मैं थाने का डिस्टेंस अगर कार से मेजर करूंगा तब तो हमेशा कम होता जाएगा ना. Whereas नेरुल और थाने का डिस्टेंस तो कांस्टेंट है ना, फिक्स्ड है ना. So it is always better to choose a fixed point. Both the ends of the rope are moving. If one end was fixed, there was no problem. I could have chosen from that fixed end. But since both the ends of the rope are moving and the edge of the table is always steady, I will choose the second. I will choose the second alternative, right? I hope ये सबको समझ में आ रहा है. Always choose distances which are from fixed points. Okay. So now I have to introduce a new variable. Let this be y. Therefore, the thickness of the element will be equal to dy. Okay. Now what I want to do is I want to apply. अब हम अर्जुन मोड में आ गए हैं. So apply work energy theorem on element. So I want to find work done by earth on the element. Please notice that here also I've used the D term because the work done by the earth on this element will be teeny tiny part of the work done by the earth on the whole chain. So dw earth. So this is a series of mathematical steps which you guys have to understand. So dw earth. So let me just write it first. dw earth is equal to minus dm g y. So what am I writing here? क्या लिखा है? So this is the physical quantity that is to be found for the element. This is the mass of the element. This is the distance mass goes up as the rope is pulled completely onto the table. Okay, minus sign because it is going up. So this is dw, since work done on element will be infinitesimally small. ये आया सबको समझ में जो मैंने लिखा है यहाँ पे? Okay. I'm going to change the slide. So the next mathematical step is figuring out the value of dn. So we are going to use the unitary method. याद है सबको unitary method? क्या होता था? 5 आदमी एक काम इतने दिन में करते हैं तो एक आदमी काम कितने दिन में करेगा? So length L of the rope contains mass M. So यहाँ पे is given in the question. Rope का mass M, length L. So length L of the rope contains mass M. Therefore, unit length will contain M by L. Therefore, a length dy will contain M by L into dy. And this must be dm. Okay, now why am I doing this? Why am I changing? Why do I need to apply the unitary method? Why should I figure out the value of dm? The answer is here. The answer is very straightforward. The answer is here. You cannot integrate at this stage. Okay. Integration is impossible since RHS contains two variables. Right? I hope you can see RHS contains two variables, dm and y. Y is a variable which you have introduced. You cannot integrate y with respect to dm, not possible. So you need to convert dm into dy, which is what I'm doing here. Okay? So this must be dm. Therefore, dw is equal to minus m by l, ये तो numbers हैं, constants हैं, dy into g into y, which I can write as minus mg by l into y dy. Therefore, work done on the chain or the rope will be equal to the sum of work done on all the elements will be equal to minus mg by l, ये तो constant है, integration के बाहर आ गया, integration of y dy. Now, I have told you, and this is the last step now. Excuse me. I have told you that the integration in physics cannot be carried out without limits. बिना limits के आप integration नहीं carry out कर सकते. So the final step that you will have to go through, the mathematical final step that you will have to go through, is to find the limits. Find the limits. What you do is that in the diagram, you look at elements which are at the extreme position. This guy and this guy. And you ask, what is the value of y for this guy? And again you ask, what is the value of y for this guy? Now you may say कि आपने ये क्यों नहीं चूज किया या ये क्यों नहीं चूज किया. बिल्कुल कर सकते हैं, इसको भी कर सकते हैं, क्योंकि इसके लिए y का वैल्यू, इसके लिए y का वैल्यू, इसके लिए y का वैल्यू, सबके लिए y का वैल्यू सेम है. राइट? y क्या है? एज से वर्टिकली डाउन डिस्टेंस. तो एज से वर्टिकली डाउन डिस्टेंस इसके लिए भी 0 है, इसके लिए भी 0, इसके लिए भी 0. और इसके लिए क्या है y की वैल्यू? इसके लिए क्या है y की वैल्यू? तो सबसे नीचे है. इसके लिए क्या है y की वैल्यू? व्हाट इज द वैल्यू ऑफ y फॉर दिस गाय? रिमेंबर इट इज, हाँ, यहाँ से डिस्टेंस है, सो इट इज l/3. So this will have limits 0 to l/3. Therefore, we get minus mg by l into y square by 2, 0 to l/3, which is equal to minus mg by l into l square by 8. L और L कैंसिल हो जाएगा. This will be minus mgl by 18. Please take a screenshot of this or write it down. I'll wait. And then we'll do the final step. We'll solve the question. y की एरो कहाँ से कहाँ जा रही है जो है, ऊपर से नीचे की नीचे से ऊपर. That will, the limits will depend on your choice of the it will depend on the choice of the variable that you have chosen. Y क्या है? It is the distance of the object from the edge of the table. इसलिए limits are 0 to L by. हो गया ना? I will change the slide now. Complete the question. For the chain, summation of work done must be equal to 0. Why? Why should it be 0? Slow process. Slow process में it is guaranteed that kinetic energy does not change. Therefore, work done by the force F, which we have to find out, plus work done by earth must be equal to 0. Actually, यहाँ पे work done by normal reaction भी है, लेकिन I don't want to write that because I know कि 0 आने वाला है. So this gives me work done by F minus mgl by 18. L by 18 is equal to 0. Work done by F is equal to mgl. Okay, now this requires a lot of practice. आपको immediately नहीं आने वाला है, और this question, इस type के question इस chapter में. So in the next class, I'll show you one more question. In your booklet, in HCV, you might have a couple of questions. Limits of integration केवल देखना है ना विश्वजीत, आप वही इसमें मैं कोई अचंभा मैजिक पुलिंग अ रैबिट आउट ऑफ द हैट नहीं कर रहा हूं मैं. आप रोप के एक्सट्रीम एलिमेंट्स को देखो. ये एक एक्सट्रीम एलिमेंट है रोप का, और ये एक एक्सट्रीम एलिमेंट है रोप का. ये भी एक एक्सट्रीम एलिमेंट है as far as y is concerned. y की वैल्यू इसके लिए क्या है? y की वैल्यू इस एलिमेंट के लिए क्या है, और y की वैल्यू इस एलिमेंट के लिए क्या है? आ गया लिमिट्स, आ गया लिमिट्स. है ना? Sure. So अब आगे बढ़ रहा हूँ. We are moving ahead. I will come back to this method again once more. But for now, I want to talk about the concept of potential energy. So before I talk about potential energy, uh, before I talk about potential energy, let me first. ये बहुत ही weird सा approach है. Let me try. So to define potential energy, I must first talk about something called multivariable calculus. Okay. Now, what is multivariable calculus? Well, it's the same as normal calculus, but उसमें variables ज़्यादा है. So, if y is equal to some function of x, okay, then dy by dx is equal to dy by d. I can just write this identity, and then I can say that dy is equal to dy by dx into dx. So what is this? What is this? What is this? This is the change in x. This is the change in y. And this is sort of the proportionality for change, change in x and y. Right. So dy by dx is basically a proportionality between change in x and y. What this means is that अगर dy by dx बहुत ज्यादा होएगा, अगर स्लोप बहुत ज्यादा होएगी, तो for a corresponding change in x, the change in y will be large. और अगर dy by dx की वैल्यू बहुत कम होएगी, then the corresponding change in y for a particular change in x will be small. Right? This is what calculus means. Right? So this is basically what happens. Single variable calculus. And now what I'm about to write, you may or may not understand. Don't worry about it. You have to understand what is coming at the end. So if u is equal to some function of x and y, then du is equal to change in u is equal to, okay? And I'm going to sort of extrapolate from this. Change in y is equal to dy by dx into dx. So change in u is equal to df by dx into dx plus df by dy into dy. Please notice the symbols that I've used are slightly different, and I think we have discussed these symbols before. So del f by del x means that you are differentiating f only with respect to x, although f also contains y wale terms, but while differentiating only with respect to x, you are simply saying that all the y terms are being treated as constant. Similarly, del f by del y, which is called partial differentiation. Del f by del y is the differentiation of f with respect to y, keeping all the x terms as constant. अगर वहाँ पे z terms भी रहेंगे तो उससे कोई फर्क नहीं पड़ेगा, क्योंकि वो भी कांस्टेंट हो जाएगा, ठीक है ना. Now I'm going to change the slide. Please take a screenshot. I am going to change the slide. Please take a screenshot. Now, if you remember, हमारे पास पहला जो वर्क डन आया था, that was integration of y dx plus x dy. Okay? याद रखना, ये पहला जो हमने वर्क डन फर्स्ट फोर्स के लिए निकाला था, and the force was y I cap plus x j cap. The answer that we found was 7 joules for the 4 paths. याद है ना ये सबको? Everybody remembers this, right? Everybody remembers this? Okay. So I am going to write this. I am going to write this as rewriting dw is equal to y dx plus x dy. And I hope nobody has a problem in this, because अगर मैं दोनों तरफ इंटीग्रेट करूंगा, तो ये चीज तो w बन जाएगी और इसका हमें वैल्यू निकालना होगा. मैंने केवल इंटीग्रेशन साइन को वहां से हटा दिया. So dw is equal to y dx plus x dy. Now this looks, if you look at this very closely, this looks very, very weird. This looks like this. So there is a term multiplied with dx and there is a term multiplied with dy. Okay? And if I were to sort of just extrapolate, then I would get del f by del x is equal to y, right? Comparing with previous statement, comparing with the theorem that I've just written, and del f by del y is equal to x. Okay, comparing with this thing. Can you think of a f for which this is true? Can you think of a function which has both x and y in it? So when I differentiate with respect to x and only with respect to x, I get a y. And when I differentiate with respect to y and only with respect to y, keeping x constant, I get an x. नहीं, इसको करके देखो अभिजीत, इसको करके देखो, नहीं आएगा। अगर y कांस्टेंट अभिजीत तो वो चला जाएगा ना। हाँ जोए, वेरी गुड, यस। अरे मतलब विश्वजीत यार, विश्वजीत y कांस्टेंट हो जाएगा ना उसमें। जीरो हो जाएगा ना। हाँ अब सही निकाला। नहीं अभिजीत, हाँ धनुष बिल्कुल सही। बाकी लोग, केवल ये 3 लोग सोचेंगे। अभिन, धनुष कहाँ गया यार, कुछ तो बोल। रजत, रजत तो तेरी शक्ल फिर से चेंज हो गई रजत। सोनल, कर्ष, ओमकार, अर्पित, आओ भाई। हाँ तूने दिया। हाँ हाँ ठीक है ना, नहीं देखा मैंने। हाँ बिल्कुल सही है धनुष, बिल्कुल सही है। यस यस यस। एनीबॉडी एल्स? नहीं, हाँ अब सही निकाला। सो f is equal to xy. Del f by del x will be equal to y, because y को कांस्टेंट मानेंगे। x into कांस्टेंट डिफरेंशिएट करो, कांस्टेंट आ जाएगा। del f by del y, अब x को कांस्टेंट मानेंगे, कांस्टेंट into y का डिफरेंशिएशन कांस्टेंट। Now see what I'm going to do. Now see what I'm going to do. So dw is equal to dw is equal to du। ये कैसे लिख दिया? ये क्या हो गया? So here you will notice that du is equal to del f by del x into dx plus del f by del y into dy, right? So I have assumed that this whole quantity, यहाँ पे बेसिकली लिखा हुआ है del f by del x, यहाँ पे लिखा हुआ है del f by del y. So dw is equal to du is equal to dxy. Because you have just told me the value of f is xy. Okay. Therefore, work done, which is integral of dw, which is now integral of du, which is integral of dxy, that is the value of u, right? u is this function of xy, right? u is this function of xy. du is equal to del f by del x dx plus del f by del y dy. Okay. And here you are writing this. Here you are writing this as del f by del x, del f by del y. So dw is nothing but du, same. कोई अलग चीज नहीं है. और if you are not really comfortable with this, छोड़ दो इसको, हटा दो, काट दो, कोई मतलब नहीं. लेकिन तब भी dxy तो आएगा ही, क्योंकि ये w की वैल्यू तो xy ही होगा. What are the limits of integration? 1, 1 to 2, 4. Right? Integral d something is what? Integral dx is x, integral dt is t, integral d theta is theta. So integral d something is what? That something. तो ये हो जाएगा x into y from 1, 1 to 2, 4. Right? Let's put in the limits now. I know this is weird for you, but this is multivariable calculus. And multivariable calculus, you see, we are doing an integration. You have never seen this before. Okay? You are doing an integration which involves two variables. But since those two variables are after d, therefore the answer will be simply that two variables. And then you are supposed to put in the limits here. X की जगह ये, y की जगह ये, फिर x की जगह ये, y की जगह ये, and subtract. This is multivariable calculus. This is the same as single variable calculus. So this will be 2 into 4 minus 1 into 1. That is 8 minus 1. That is equal to 7 joules. So I already knew the answer to this question. And I knew that whatever path I give, I will always get 7 joules. I knew this. Okay. Please take a screenshot. I'm going to the next screen. Please take a screenshot of this. Everybody, please take a screenshot of this. Let's try the other one. W is equal to integral of 2xy dx plus x square dy. हाँ अब उसका काम ही नहीं है ना. वो जो ट्रिक मैंने बताया था उसका फिलहाल कोई काम नहीं. We have now moved beyond that trick. So dw is equal to 2xy dx plus x square dy. This implies that del f by del x is equal to 2xy and del f by del y is equal to x square. So what is f और w? सेम चीज है. f और w सेम चीज. क्या फंक्शन है वो x y? जब हम x के रिस्पेक्ट में डिफरेंशिएट कर रहे हैं, y को कांस्टेंट मान रहे हैं, 2xy आ रहा है. जब हम y के रिस्पेक्ट में डिफरेंशिएट कर रहे हैं और x को कांस्टेंट मान रहे हैं, तो x स्क्वायर आ रहा है. व्हाट इज दैट f और w? नहीं, x क्यूब नहीं आएगा ना अभी. वहां पे हाँ, बिल्कुल सही आंसर होता है. बिल्कुल सही है जोहर. और कोई? x स्क्वायर y. नहीं शुजोत, एक्स वाई नहीं. एक्स वाई को डिफरेंशिएट आप x के रिस्पेक्ट में करोगे सिर्फ y आएगा. लेकिन यहाँ तो 2xy आया हुआ है ना. राइट. सो dw is equal to dx square y. So w is equal to x square y from 1 comma 1 2 comma 4, that is equal to 4 into 4 minus 1 into 1 is equal to 16 minus 1 is equal to 15 joules. And I already knew, the moment I gave the question, I knew that the answer will be 15 joules, irrespective of the path. Okay? Irrespective of the path. For the third force, W is equal to integral of x y dx minus y dy. So this will be dw is equal to xy dx minus y dy. So this implies that del f by del x is equal to xy, and del f by del y is equal to minus y. What is f? ये third वाला question. ना गलत आंसर लीजिए, लेफ्ट और राइट करके देखो. It is my guarantee. Right? It is my guarantee that you will never be able to find f. It is my guarantee that you will never be able to find f, because such an f does not exist. Because such an f does not exist. For which, if you differentiate with respect to x keeping y constant, you get xy. And if you differentiate with respect to y keeping x constant, you get minus y. It is not possible. हाँ ज़ोहर, अब समझ में आया ना, तेरे को क्षमता, तेरे को कुछ हाँ. So f not possible. Therefore, I knew that different paths will have different answers. Okay, therefore I knew that different paths will have different answers. Please take a screenshot of this. I want to just tell you one more thing. Therefore, I knew that different paths for this force will have different answers. Please take a screenshot. Please take a screenshot of this. Please take a screenshot. So, forces for which this U can be found. The work done is independent of path. Therefore, forces are called conservative forces. Okay? And the biggest statement is, and this U with a minus sign is called the potential energy of this force. Right? So you can have the term potential energy only for conservative forces. Conservative forces are those forces for which work done is independent of path. Work done is independent of path if you can find an expression for u in the first place. Right? The whole circle is completed. So therefore, this force is conservative. Okay, I'll write it in blue now. Therefore, F is conservative and potential energy is equal to minus xy. ये इसका minus. Please take a screenshot again. Please take a screenshot again. नहीं ट्रिक नहीं है कोई एक 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 टेस्ट है मैं बता दूंगा कैसे करना है. I'll tell you. Don't worry about it. कोई ट्रिक नहीं अप्लाई करना है, कोई चीज याद नहीं रखना है. फॉर्मूला याद रखना होगा जो मैं बताऊंगा, बाकी और कुछ नहीं याद. Please take a screenshot. इसके लिए therefore F is equal to 2xy I cap plus x square j cap is conservative and potential energy is equal to minus x square. Okay. Therefore, F is equal to xy I cap minus yj cap is non-conservative. And work is dependent on path. Okay, please take a screenshot. And finally, please take a screenshot if you have not. Okay, we'll end here. We will end here. And I'll see you guys in the next class. सत्यम, मैं तभी तो स्क्रीनशॉट तब से चिल्ला रहा हूँ, स्लाइड में नहीं भेज पा रहा हूँ. जल्द तभी कोशिश करता हूँ. लोचा. चलो भैया. स्क्रीनशॉट. हैप्पी न्यू ईयर जो है, हैप्पी न्यू ईयर टू एवरीवन.
हैप्पी न्यू ईयर सर.
स्क्रीनशॉट लो पहले. स्क्रीनशॉट पहला, दूसरा, तीसरा, थर्ड स्लाइड, फोर्थ स्लाइड, फिफ्थ Fifth slide. Fifth slide. Sixth. Sixth. स्क्रीनशॉट लेना आई होप सबके लिए आसान है. Seventh. Seventh. Eighth slide. Ninth slide. Chalo bhai, happy new year to everyone. Hopefully we'll get rid of corona in this new year and we'll be together face to face. Chalo, happy new year to everyone. Happy new year. अब इसके बाद क्लास नहीं है ना? क्यों विवान? क्लास है? हैप्पी न्यू ईयर अभिषेक. तो मैं मीटिंग एंड कर दूं फिर? हाँ, स्टूडियो से अगली क्लास आई विल ट्राई टू टेक इट फ्रॉम द स्टूडियो. चलो, ओके गाइस, ओके, चलो. ओके, बाय बाय.